Okay, good morning, friends. So, in yesterday's class, as you know, we discussed about various diseases caused by microorganisms, especially bacterial diseases, viral diseases, and mycoplasmal diseases. Apart from that, we also discussed about pests, pest diseases that are very common on important cash crop of India, that is cotton. So, I'd like to give you a brief review before starting today's class. So, as you know, regarding these bacterial diseases, and of course, in almost all the diseases, the necrosis, leaf spots, hypertrophy, hyperplasia, galls, tumors, wilts, rolls. These are some of the symptoms, common symptoms in almost all the plant diseases, especially caused by microorganisms. And yesterday we discussed about, of course, hundreds of diseases are there that are caused by bacteria in our food crops, vegetable crops, and orchards. And we confine only ourselves only to important staple food of India, that is rice. That is what are the important bacterial diseases that are common on rice. We discussed about, in a blast, that is bacterial blast. Bacterial blast, Xanthomonas oryzae. We discussed about that, how pathogen enters and to what extent it causes loss, etc. And this blast is nothing but complete burnt, symptom exhibited by the entire field. And apart from that, we also discussed about canker in citrus. Citrus canker, as the name indicates, this is common in Rutaceae family or citrus fruits. Your sweet lemon or nimbu, what we call in oranges, in Botany. Generally, we come across this, and generally these cankers are found on leaves, on branches, even on the mature stem also you will see. And at last, you will also see this cankerous growths, corky growths, even on fruits. So these warty, corky structures that are seen growing on different parts of the Rutacean members is very, very common. And the common symptom, the distinctive symptom of viral diseases, which differs from other diseases, the bacterial diseases, they ooze liquid. Liquid oozes from the damaged parts or the infected or necrotic or rotted parts. And that it emits some foul smell. And if you take that drop on a slide and observe on a microscope, you will see lakhs and lakhs of bacteria. Then coming to viruses, of course, they are microscopic, particles as such. They don't have their own machinery of reproduction. Whenever they come across a suitable host, then only they show living characters. Or else, outside the living host, they are similar to our river salt particle or a pebble or a rice, or a sand particle as such. They don't exhibit any living characteristics. When they make an entry into host cell, then only they show these living characteristics. Of course, we have seen two important, of course, here also number of diseases, necrosis is there, wilts are there, spots are, especially variegated, shades on the affected parts, tulips clearance we have seen, and tobacco mosaic virus we have seen. So under this, generally viral diseases, we discussed about two important diseases, that is tobacco mosaic virus, wherein the leaf exhibits variegated various shades of yellow and green. That what we call mosaic symptom. And not only that, it affects the yield and also the quality. So even the leaf becomes, or the plant becomes stunted. The size of the leaf gets reduced. Not only the size, but even the quality also gets reduced. The other day, viral disease we discussed was about chungro virus. Chungro virus, very common on rice. Even on other crops also, you will find this tumoro virus, but we confine ourselves to only to tumoro virus, wherein there are two, rice tumoro the bacilliform virus and spherical form virus. These are the two, either solely or in combination, affect in all the rice growing areas. And this tumoro is nothing but reduced or detrimental, reduced growth. So it itself tells you that there is a degeneration in the growth. So plant exhibits what we call stunted growth, and profuse tillering will be there, and generally late maturity will be there. And if the plant or if the virus affects seedlings, generally you don't see any panicle coming. And if it affects at later stages, even the panicle bears what we call choppy seeds. So a lot of damage will be there. And this is very common in almost all the South Asian nations where the rice is grown. And here, the spread will be by an insect. Nephrotic virescence is the insect that is responsible for transmitting this. Of course, then moving to your mycoplasma. Generally, they are considered as the smallest organisms, smallest prokaryotes, and differ from bacteria having no definite cell wall. Hence, the antibiotics are ineffective if you use antibiotics against this. And under this, we discussed about two important diseases. Little leaf of brinjal was there, wherein, as the name tells you, leaf becomes small and plant becomes very short, and even no fruiting will be there. Even if fruits bear, they will be corky, no juice will be there. And last one was a grassy shoot of sugar cane, wherein sugar cane shows profuse tillering, and instead of one stout main stem, you see number of grass-like stems coming from the base, and your milling character, it loses its milling characteristics, and juice will be very, very less. So these were the bacterial, viral, and mycoplasmal diseases we discussed about. Apart from that, we also discussed briefly about pests, especially pests on cotton. Cotton, an important cash crop, and cotton is we discussed about two important pests. So whenever we speak of pests, it relates to insects. So generally, two important insects we discussed about. One was the what we call the insect that lays eggs on the leaves, and the larvae that they move gregariously and cause a lot of damage to the crop. And that we discussed it, and that was what we call the tobacco cutworm. Of course, nothing to do with tobacco, but the name is tobacco cutworm. Spodoptera litura is the pathogen or the pest that is responsible for this. And here, to control, will be erecting sex pheromone traps or light traps, etc., or by using insecticides such as phosphorus-containing chloropyrifos or phenithrothion, or some of the dichlorovas are the phosphorus-containing insecticides that are found to be very, very effective in controlling. And the other thing we discussed was about cotton aphid, that is Apis gossypii. Here the insect reproduces. The female reproduces by parthenogenetically, and by viviparously it produces young ones. In each insect may produce some 8 to 24 nymphs, and these feed they found on the underside of the leaf, and they suck the sap and thereby cause a lot of damage. Not only leaves, but also they suck sap from the young shoots and also from the young balls. So this we discussed in our yesterday's class. Then uh, then we move to today's class. In today's class, we'll discuss about important pests of paddy and the storage pests. And also we discussed about angiospermic parasitic plants. Angiospermic parasitic plants. Now to begin with, the paddy, of course, he has given in this syllabus, they have given you the importance of paddy. Of course, even I told you in my earlier classes also, it forms, the staple food for more than 50% of the population. And because in South Asian countries and in China and India, the staple food is rice. So now, in generally, we have three major varieties in rice. Of course, there are roughly 90,000 varieties are there. This is the only crop where such a large number of varieties are there in rice crop. Of course, rice is Oryza sativa. This is the species, of course. And the varieties are primarily three major types: indicas, japonicas, and javanicas. As the name tells you, indicas are popular in India, Indian subcontinent, and the japonicas and javanicas are short-statured, early maturing, photo-insensitive, and the seed will be small. And when you cook the rice, it will be sticky. Generally, Indians, we don't prefer this. In India, we have, lengthy, rice grain will be lengthy and non-sticky. And, this, apart from white, generally, the number of varieties of rice are there. Of course, to mention, your white, which is very popular, of course. Now there is nowadays, people are preferring what we call brown rice. Even black rice is there, red rice is there. The other famous one is what we call basmati or scented rice. So these are the rice, and of course, rice, staple food because it is very rich in carbohydrates. In addition to carbohydrates, is very rich in proteins. Alluron layer is there, and even vitamins, essential vitamins and essential amino acids are there. And generally, the gluten content is very, very less. Hence, this has been the staple food for thousands of years. So there is a history shows that we know about this for the last 1,000 years, or so more than 1,000 years BC. We are acquainted with the cultivation of this rice, especially in the Indian subcontinent. Of course, the other economic importance, generally in rice, other forms of rice, generally what we call murmure, and the what we call pressed rice or atkulu, and of course our rice. And apart from this, some other countries like in Japan, by fermenting the rice, they prepare an alcoholic drink called sake, an alcoholic drink. So, and coming to the vegetative parts, the whatever the straw will be used as a fodder, and from the straw ropes will be made, and for thatching, huts it is used, and for making poor quality paper it is being used. And the husk in the miller, when you take this paddy to the mill, the husk what you get, that will be used in brick kilns, and also the rice bran oil nowadays. It's a cooking oil, of course. It can be used in soap making and other industrial purposes. And nowadays, even biodiesel is also being prepared from rice. Now, this is about briefly about the rice. Now we move to various insects. The important insects or pests that are common in paddy. Of course, number of insects are there. See, I'll just read out. Green leaf hopper is there. A brown leaf, as the name tells you, green. It is green, green leaf hopper. Brown plant leaf hopper is there. Paddy stem borer is there. Leaf folder is there. Swarming caterpillar is there. Gall midge is there. Rice skipper is there. Spiny beetle is there. Mealybug is there. Thrips are there. So like this. So some 15 to 16 different types of, insect pests of paddy are known. Of them, in our syllabus, we confine only two. One is what we call green leaf hopper, and the other is paddy stem borer. So these are the two major, devastating pests that are common in all the rice growing areas. So one is the green leaf hopper, the other is paddy stem borer. Now this green leaf hopper, as the name tells you, green leaf hopper, as the name tells you, it is green, and it's sometimes they'll ask you the scientific name, Nephrotics virescens. So even I told you about this. This is the insect that transmits tungrovirus. So green leaf hopper. So the damage caused by green leaf hopper to the rice is, when compared to its transmitting ability of the tungrovirus, its damage either by the adult green leaf hopper or its maggots is less when compared to the damage it causes by transmitting tungrovirus. So generally, this is the typical leaf hopper. It is green in color, as I already told you, with black spots. And the nymphs will be, that is, young ones will be yellowish green in color. And generally, this is nothing but a kind of camouflage. That is, all insects try to, escape from the enemies by showing, mimicking the surroundings. So when the storm matures, when the rice matures, it generally turns what we call yellow. So the young ones, generally they are yellowish in nature, and the adult one will be green. So when the plant is green, when the leaves are green, generally you will see green leaf hopper. By the end of the season, generally the adult one lays eggs and they hatch into young ones, and which are generally yellow greenish with black spots. So as I already told you, generally the loss caused by this to the plant is less when compared to the loss it brings by transmitting tungrovirus. So generally this the insect, generally it perinates, it overwinters, over summers in the stubbules or in the fallen leaves. So on the fallen leaves, you will see the eggs and the maggots will be there. And when you harvest, you leave the stubbules. So even the insects' eggs will be there, or the adults will be there on the stubbules, and also the various graminaceous, weeds that are seen growing along with the, this rice. They also harbor the insect eggs and larvae. So that is, so hence what we should do to avoid this pest. You should maintain sanitation. You have to remove the stubbules. You have to clean all the channels, all the hedges, all the bounds. They have to be kept very, very clean, so that the recurrence of this leaf hopper can be prevented. So generally, the conditions which prefer the increase in the number of population and the damage to the crop will be when there are low rainfalls, when the bright sunlight is there, when the temperatures are very high, when the rainfall is low, and these are the conditions which are quite favorable for the reproduction of the moth, and excessive use of nitrogen and the staggered planting. So while plantation, transplantation should not be staggered. So taking all these precautions, we can save our crop. So generally the plant exhibits, stunted growth, and the leaves will get deformed, and increased tillering. Tillering will be there, of course. The panicles will be very small, and they bear only very few number of seeds, and the gall formation will be there, and leaves become yellowish. So whereby the yield gets affected. Not only the yield, but even the quality of the seed also gets affected. Now, how to control? So generally, the best way is to go for the insect-resistant varieties. Insect-resistant varieties such as IR50, CR1009, IR22, IR46 found to be very, very effective against attack of this pest, green leaf hopper. So by going for the disease or hopper resistant varieties, the one way. The other is, I told you, cleaning the bunds and the channels of the weeds, which harbor the insects and their young ones or the eggs. And and the third thing will be spraying insecticides. And the other is setting up what we call light traps and sticky mats. So by light traps, they get attracted to the light and they get struck to the either fire, they get killed, or when you put what we call sticky traps, they get struck, get glued to that, and they die there itself. So the other is nowadays, it has been found, by applying the neem cake, it has been found that you can keep the insect population at low. This is about the green or leaf hopper, green leaf hopper, that is very, very common in rice. That is Nephotetics virescens. And then we move to the second most potent damager of rice crop, second potent pest that is very, very common and cause a lot of damage to rice is paddy stem borer. Paddy stem borer, otherwise known as yellow stem borer, and its scientific name is Cyphophaga incertulus. Cyphophaga incertulus is the scientific name, and this is, this comes under your objectives. The scientific name of stem borer. So, Cyphophaga incertulus is the scientific name. And coming to the, pest, description of the pest, generally the moths, generally the adult female moth is very, very big and bright yellowish in color, and with bright, forewings will be bright yellowish, and forewings has black spots, and the hind wings will be light yellowish and hairy. And generally, when compared to female, male moths will be very small in size, and generally they are pale in color with forewings having no black spots. So it is easy for us to distinguish the male and female. If the wings have, black spots, it should be recognized as a female moth, and wings having no black spots tells you that it is a male moth. Now, these female moth, it lays eggs, and which hatch into what we call larvae, which are pale yellow in color. And generally, the damage caused by the adult moths is very, very limited. The adult moths lays eggs, large number of eggs, and which in due course hatch into caterpillars. And these caterpillars are the young ones. They move gregariously, and they are voracious feeders. They feed on the leaves. So caterpillar damage will be very, very large, and especially in the stem borer. Why the name? The caterpillar, after hatching from the egg, it makes an entry into the central part of the stem, and eats away the conducting tissue, so that the leaves get drooped and they get dried, and ultimately the plant dies. So as it is affecting the central part, hence this is otherwise known as dead heart disease. Heart is central part of the stem, the conducting tissue. It dies. Hence it is called dead heart. And if this caterpillar makes an entry at later stage, then of course you will see panicle. But the panicle bears no seeds, and it looks whitish. Hence it is called white ear. White ear disease or dead heart. These are the symptoms caused by stem borer. That stem borer is nothing but Circophaga insectularis. So now, how to manage this? Generally, like leafhopper, here also we should go for resistant pest resistant varieties such as Ratna Jaya. These are the varieties. TKM6. These are found to be very, very effective against pest attack. So the thing is going for resistant varieties. The second managerial practice should be avoid stagnation. Avoid stagnation of water should be there. And generally, the proper placing should be there. The hill or the transplantation should be wide, with wide gap. If they are very closely planted, they plant succumbs to the attack of these caterpillars or the stem borer. So proper distance has to be maintained, and generally light traps should be set up so that they will attract the moths and get killed. And even there is what we call biological control method has been worked out by scientists. The egg parasitoid, a fungus, Trichogamma japonicum, found to be, it feeds on the eggs. The fungus feeds on the eggs. So this is a biological control. And the last one should be going for what we call insecticide spraying, especially monocrotophos. Monocrotophos or quinalphos found to be very, very effective in controlling the stem borer. So this is about what we call the pests of rice, especially the green leafhopper and the stem borer. Then we move to storage insects. Storage insects. So now, coming to the production, as far as the production is concerned, rice production, China ranks first, followed by India. And then, of course, Indonesia is there. And China, is the largest producer. Not only largest producer, it has been, according to an estimate in India, in other third world countries, there is a lot of, loss, damage to the produce. Because it has been worked out that around 25% of the produce, grain, is lost in the distribution chain, starting from the field, farmer's field, then threshing area. From there, you move to market. Then from market, it will move to go down, and then go down to miller, of course. Then there will be fair price shops. From there to households. So in this chain, at each step, it has been found a lot of damage, lot of loss. The transportation loss will be there. Not only that, with the attack of a number of storage pests. Storage pests are found to be doing a lot of loss for our produce. But in other developed countries like USA, some 65% of their produce will be processed. So if you do it process and if you go for proper storage, generally loss will be minimal. But in 65%, and in China, some 26% of their produce will be going for processing. But in India, we have poor processing units, and our facilities account only for 2.5. So thereby, a lot of damage, lot of loss to this produce is occurring in India and other third world countries. So the loss, should be, so a rupee earned, a rupee saved is a rupee earned. So you're not only for production, but you have to minimize loss. Minimizing the loss should be there. And according to an estimate, some 14,000 tons of food grains are lost every year, which account for 7,000 crores of rupees. See, and these storage insects, around 600 species of storage insects have been found to be infesting various storage facilities. Of them, of the 600, 100 are found to be very, very loss causing. Found everywhere in almost all the godowns. So you will come across the presence of 100 insects causing a lot of economic losses. Now, in the storage areas, the loss will be weight loss will be there. See, if infestation, if a maggot enters, lays an egg, and it makes holes into the grain, maybe whole grain or your rice, wheat, whatever the pulses, whatever the case may be, this is a common phenomenon. In your if you go to kitchen, if you observe, any produce you brought from the market and kept it for months together, if you observe them, if you don't open your lid, you will see the entire getting damage. So now and then what should do? You have to open the sacks and spread them either in the sunlight or in the shade so that the moths fly away, and by winnowing and by mixing certain disinfectants, you can keep them at bay. So the loss could be what we call weight loss, because they make holes, the entire grain gets turned into what we call powder. It looks, but if you press it, very hollow. So weight loss will be there and viability loss will be there. So they don't have any viability. You cannot use them as seed for the next crop. Commercial value loss will be there, and people generally, we don't prefer. If you find holes in the grains, you don't prefer. And consumer preference will be lost, and even the contaminated, even nutritional loss will be there. So a lot of loss will be there. So this is how the pests are causing a lot of damage to the storage products. Now, the loss, if you speak in terms of various types of insects or pests, generally insect account for 15 to 25% of loss, and rodents. So whenever I say rodents, rats and bandicoots, they account for 2.5% of loss, and birds account for 8.5%, and the moisture. If your proper ventilation is not there and no fans are there, generally moisture accounts for loss to an extent of 0.6, 0.8%. So now we move to various insects. Various insects that are common in storage areas or in the godowns that cause a lot of damage. Say rice weevil is there, copra beetle is there, lesser grain borer is there, pulse beetle is there, cigarette beetle is there, dark store beetle is there, number of. So around some 16 to 20 different types of insects are found to be very potent in causing damage, occurring large numbers in all the storage areas, especially in the godowns. So in syllabus, we have only two important these storage loss causing pests. One is the rice weevil, of course, rice moth. Rice weevil and rice moth, generally these are found infesting in wheat, rice, maize, jowar, etc. And Cytophilus vorizae, that if found in rice, Cytophilus vorizae, and the weevil that is found in maize, it is Cytophilus giamianus, and the other is granarius. These are the Cytophilus species that are commonly known as rice weevil affect wheat, rice, maize, jowar, paddy, etc., etc. So the insect will be generally, the adult will be very small and reddish brown, chocolate in color. It lays eggs singly. One egg will be laid on each grain, and that grain will be, they are rather translucent and white in color, and the egg hatches into an young one, and of course that in due course it eats away, and at the end it turns into pupa. From that pupa you get the adult. So they cause a lot of damage to the whole grain. So damage both grubs, that is young ones, nymphs, and the adult cause damage, and the grains get hollowed, porous. They become porous. hallowed and they're reduced to mere powder. If you press them, they are just hollow and it bursts into powder. And generally, the adult ones, they cut the adult one. The young ones make an entry into the grain, but the adult ones, they scrape the seed coats. They disform the shape of the seeds. And generally, the infestation, if your commodity is infected or not, you will know by what, they exhibit what we call the grains in the container. If you put your hand or if you look at them, they show, heat, the warmth. So heating commodities tells you that the produce got infested with the moths or the insect. The second one is the rice weevil, the other is rice moth. Of course, it is Coursera cephalonica is the scientific name, and it is also very common in rice, jowar, millets, and whole cereals, cereal products, pulses, etc. Even in oil seeds, nuts, and almost all even in dry fruits also, you come across this moth. Popular in rice, hence it is called rice moth. So the thing is here, even you will see, the adults will be brown in color, and their forewings are palish yellow. And the hind wings are whitish wing. And generally, the maggot, they lay, eggs which are small, oval, elliptical in shape. And generally, the young one will be, larva will be creamy in color. Of course, later on, they turn to pupa, and later on, by bursting the pupa, the young one or the adult one comes out. So generally, damage will be, larva causes a lot of damage. When compared to the adult ones, the damage caused by the larva is very, very large. So here, the larva, larva infests, with the infestation of the larva, the produce, their excretes, etc. They excrete certain sticky substances so that the grain form ball-like structures. Ranging from, half a kg to even sometimes 2 kg balls. So that entire 2 kg is mere loss. So because of this infestation, because of their sticky excretory products, the grains get glued into bog-like structures. So this is the symptom exhibited by the infestation with rice moth. And of course, the other is what we call copra beetle is there. And this is also another common beetle that you find in the stored products. So in the stored products, generally under dry, hot conditions, they reproduce very, very vigorously and laying large number of eggs, and generally in the storage, the godowns or in other storage, storage, your bins or maybe plastic or tins or whatever the case, you will see this. And here, the adult ones, generally the damage is very less, but the grubs or the young ones, they cause a lot of damage. So here, the produce becomes inferior, not only in terms of quantity, but also in terms of quality. And the area becomes unhygienic and it emits foul smelling. So hence the warehouse protection should be taken care of, or else whatever the produce you store, gets spoiled. So the management should be, the copra beetle infestation should be checked, and the young larva population are to be controlled, and generally using, the loss, ranges from 5 to 30%, and extreme cases loss could lead to 70% of, loss will be there. So here what we do is, you go for what we call use of repellents, or go for what we call fumigation. Fumigations by frequent fumigations. And generally, before you take your fresh produce to the godown or the storage area, it has to be completely cleaned in advance by exposing to hot weather, by fumigation, and even in the corners or even in the storage areas or even on the gunny bags, etc. They should be thoroughly cleaned. Even if few grains, infested grains are found, that is sufficient. It becomes the inoculum to destroy the entire produce. So the other is red floor beetle. So floor beetle, as the name tells you, your floor, your wheat flour or rice flour or jowar flour. So in all the floors, you will find this red floor beetle, and these beetles, with their excreta, this becomes unhygienic, and in maximum, even if there is a maximum infestation, the produce, the white flour becomes brownish or pinkish, light pinkish, that you cannot consume it. So this red floor beetle, it is otherwise known as a confused beetle, which cause a lot of damage to our stored flour, and also it is also found in stored grains also. So to avoid this, generally we should go for bold grain granaries. They should be dusted, cleaned, and exposed to hot weather, fumigation. And so here, physical control, cleaning, and hot weather use. Chemical control, by spraying various fumigants, in insecticides, you can check the population. But the fumigation should be only as a last resort, while you do fumigation, the aerosols may remain on the produce. So hence the fumigation should be taken as a last resort. So then now next we'll discuss about, this is about storage, pests. Now the next unit is about angiospermic parasitic plants. Generally whenever we speak, the plants, whenever we say plants, plants generally they are autotrophic. They prepare their own food, especially except your fungi. Almost all the entire plant kingdom has what we call autotrophs. Fungi are heterotrophs. But this is not completely true. Even in angiosperms, we have certain parasitic plants. Parasitic plants. Whenever you say parasitic, means here host and parasite relationship. Host that gives shelter to the parasite, and parasite draws its nourishment, either the prepared food, or it depends for the water or salts, etc., from the host plant. Thereby, the host is the sufferer and the parasite is the beneficiary. So now in angiospermic, these parasitic plants, the parasites, of course, as the name tells you, the parasites are of two kinds, complete parasites and partial parasites. Complete parasite means here they depend solely on the host for their food and for the shelter. Partial means they depend only for the water and minerals, and for the shelter they depend on the host plant. So the damage caused by the complete parasite is maximum when compared to the loss caused by a partial parasite. As it tells you, partial parasites, they have their own leaves. If a plant has leaves, means it's autotrophic. It prepares its own food. But the complete parasites, they are achlorophyllous. They don't have any chlorophyll in them. Hence, for the food, for the water, for the minerals, for everything, they depend on the host plant. So hence, the damage caused by the complete parasite is maximum when compared to the partial parasite. So now, the parasites for our convenience. For our convenience, the parasites you can group them. It has been known that in flowering plants there are 3,900 known parasitic plants, and falling in some 20 families. The important families are, for example, Loranthaceae, Convolvulaceae, Orobanchaceae, Lauraceae, Santalaceae, Belanophyraceae, Scrofulariaceae. These are the families in which you come across the parasitic plants. So now the parasites, for our convenience. The parasites can be divisible into two categories. One is a complete parasite and a partial parasite. This is one way. The other way is the part of the plant to which the parasite makes an anchorage attached to. Based on that, also the angiosperm parasites are classified. So in your textbook, the classification given is based on the part of the plant, that is the stem parasites and the root parasites. Because the parasites are seen clinging to the stem part, hence they are called stem parasites. If they are found anchored to the root system, they are called root parasites. And then the stem parasites are again two types. One is a complete stem parasite, the other is a partial stem parasite. So also root parasites are of two kinds, complete root parasite and the other is a partial root. So I told you already, if it is a complete parasite, they are achlorophyllous. They don't bear any leaf. Whereas partial parasites, they bear leaves, they have their own leaves, they prepare their own food. But in all the cases, either it is a complete or partial parasites, they have, they produce flowers, and pollination, fertilization will be there. They produce seeds, fruits and seeds. So in all the cases, they produce seeds, and these seed is the, structure for the fresh attack. So generally, they reproduce by seeds. The seeds are very, very small and minute. Some plants produce fruits, and these are taken by the birds, and through their excreta, the seeds come out, and when they fall on the host plant, they germinate and make an entry into the host plant. So let us discuss about stem parasites. So stem parasites are total parasites. This is very, very important for you and very easy for you to write in your examination. So these stem parasites, total stem parasite, it is otherwise known as a cuscuta. Cuscuta is the total stem parasite, and it is otherwise known as golden thread because the stem is yellowish in color. And of course, you will come across them in bougainvillea or in gygeosia, in crop plants, or in flax plants, even in potato, alfalfa. In all crop plants, you can come across this yellow leaf, yellow stem, no leaves. No leaves, complete plant will be yellowish. As it is yellowish, it cannot prepare its own food. And this yellow stem makes an entry into the host tissue by sending certain finger-like process known as hasturia. They enter into the host and they draw the food material. They make an contact with conducting tissues, phloem and xylem. Thereby, they draw their requirements. So here under short note also you may get it. Write briefly about cuscuta or the total stem parasite. Or under objective type, what is the common name of cuscuta? Or which of the followings has the common name as a dodder or golden thread? So cuscuta is otherwise known as dodder or golden thread, and its hosts are alfalfa, clover, flax, potato, bougainvillea, gygeosia. This is a stem parasite, and it flowers, fruits, and it produces a lot number of seeds. And because it is a stem parasite, solely depending on the host, it causes a lot of damage to the host. So thereby, the plant becomes shows, or the crop plant shows stunted growth, and the leaves get shriveled and the plant dies. And the partial stem parasite example for this is Loranthus, is otherwise known as giant mistletoe. And generally, this Loranthus is very, very common. You can see while walking on roads, if you observe very closely big trees such as your neem tree, mango tree, or in citrus or guava, etc., you can come across, this Loranthus. The leaves are leathery leaves, and they are sickle-shaped, very leathery, greenish, dark green leaves are there. And you will see flowers, tubular flowers, white or lightly red, flowers you can see, and it reproduces by, by fruits and seeds. And generally, the birds and young birds visiting, they eat these fruits and drop through their droppings. They leave the seeds, and when they fall on this mango or your guava or neem, they germinate there and make an entry, make a contact with the xylem, because it is a partial parasite. It gets connected only to xylem, not phloem, because it prepares its own food. Then root parasites, of course, we have both the complete root parasite and the partial root parasite. So now the complete root parasite example for this is what we call Orobanchi. Orobanchis is the family to which it belongs. And Orobanchi, the common name of Orobanchi is what you call broom rape or tokra. Broom rape or tokra is the common name for Orobanchi, which is a total root parasite. Generally, this is very common in tobacco. In tobacco fields, if you go and observe, you will see this Orobanchi. This is, it comes out, above the ground, grows some 30 to 40 centimeters, and you will see stem will be there, and the scaly leaves will be there, and the plant is not green because it is a complete root parasite. Now here, if you closely remove, the superficial soil, if you go deep, you will see connection between the root system of the tobacco with the roots of this broom rape or Orobanchi. So as it is attached to the root system, hence it is called a root parasite, as it bears no leaves and depends completely for its food on the tobacco, hence it is called a complete root parasite. Apart from your tobacco, it is also seen in tomato plant, and also in brinjal, cauliflower, etc. So if you go to a tobacco crop area or tomato or brinjal, then if you observe very, very closely adjacent to these plants, you will see this non-green brownish Orobanchi. Now here, the thing is, Orobanchi, it produces, of course, flowers, fruits. Seeds are very large number, very, very minute. And when the plant matures, or when the fruit, the capsule, when it bursts, it releases its seeds and they fall in the seed, in the soil, and they remain in the soil for many years. So if you want to protect your, crop, maybe your tobacco or tomato or brinjal, etc., you should go for what we call crop rotation. So the seeds, which are very small, are viable for 3 to 4 years. So hence, the seed, the soil treatment should be there, and you should pluck them before they produce seeds, so that you can protect your crop. Not only this crop, but also future crop. So Orabanki, Broombrae partokra, of course, very, very common in Solanation members, especially the tobacco. Okay. So the other is partial stem parasite is Striga. Commonly it is known as Malle in Telugu. So generally it is otherwise called witchweed. Is otherwise called witchweed, Striga. Generally you come across them in monocotyledonous crops, especially in sorghum, maize, and sugarcane. In sugarcane crops fields or maize crop fields or sorghum crop fields, if you observe very closely, you will see small. So the plant is Striga is greenish because it is a partial root parasite. It bears its leaves and also flowers. White flowers will be there, very small plant. And you will see if you remove the topsoil, you will see that Striga roots are having connected to the root system, fibrous root system of these monocots, such as sorghum, maize, and sugarcane. So both Orabanki and Striga, they produce large number of seeds, and these seeds are very, very small and microscopic. They remain in the soil, and when there is a gust of wind, they because they are very small, they get transmitted from one field to the other field, or when irrigation, or when there is a flooding, when there rains, even along the rainwater, they may get, moved from one field to other field. So recording the infection of the fresh crop, generally in Orabanki and Striga, both are root parasites, when the seeds that are there in the soil, they germinate only when they're proper, when the host plant is available. The host plant secretes certain secretions. It produces certain secretions that contain specialized chemicals. Those chemicals induce seed germination. So hence, only when those particular plants are available, unless until they are available, they cannot make an entry. They cannot get contacted to the other plants if you sow. So only when tobacco is there, tomato is there, brinjal is there, they secrete special type of secretions having, specialized chemicals that induce seed germination of this Orabanki, and also this in the Striga also, the sorghum, maize, and the sugarcane, they are found to secrete certain secretions that stimulate, so that root exudates. Only when root exudates are there, then they induce seed germination. And of course, the seedling makes a contact with the root system of the host plant. Thereafter, it develops, germinates. So also, even I told you in Striga also, it also, the root exudates. Strigolactone is secreted by the host plants such as maize or sorghum that contains strigolactone that uses the Striga seeds to germinate and ultimately come in contact with the root system. So here, in almost all the cases, what you have to do in case of root stem parasites, maybe your partial stem or complete stem parasites, then you can physically remove them. Physically, because they're macroscopic, you can remove them, plug them. The other is by spraying certain herbicides. Herbicides such as 2,4-D, 2,4,5-T, or glyphosates, etc. By spraying them, you can check the population of these stem parasites. If it's a root parasite, generally the managerial techniques differ, because here underground parts, as the seeds are there, so generally the best thing is to go for what we call crop rotation, and sowing or spraying a glyphosate like pre-emergence herbicides can be there, or 2,4-D, 2,4,5-T herbicides can be there, or weeding and intercultivation has to be frequently taken. And so these are some of the things by which you can check. So of course, so with this, we come to an end of this. And if you have any doubts, you can raise your doubts regarding this, or else we will call it a day. And our next class will be on the next Friday, Saturday, and Sunday. So we have completed almost 50% of the syllabus, and the leftover 50% will be covered in the uh, coming 3 classes, that is Friday, Saturday, and Sunday. If you have any doubt, you can raise them, or else we will close for today. If no doubt, let us call it a day. Thank you.